audio. I'm just using device. So Omer, are you here? Okay, so in the following weeks, we can do the setup that we talked about. Um, cool, and we'll start recording. So do a screen share first. All right, so the recording is whatever you can see on this particular on the projectors. So everything that is on the projector, if everything works out, should be recorded. And I am going to start the recorder. So start. Oh, it's already recording because I set it up to automatically record. So my voice is recorded, and so is whatever you see on the projector. If you don't see, this part here on the screen, that means we are not recording, and you might want to remind me to do the recording unless you do not think that is of any value, then it's okay either way. So are we good so far? All right. I don't think anyone has any issue with me recording because there's no video camera pointing in your direction, nor actually, I'm not in, my face is not on the recording either. But if you ask questions in class, your voice, can be captured by the mic. So does anyone have any issue with that in terms of privacy? No? Okay, all right, cool. All right, so we can officially start the class. And I'm just going to nag people and say that you have to take care of your prerequisite and co-requisite requirements for this class. So do we have any questions about that portion? Because I see that many people have done whatever is necessary, and I have quote unquote graded those particular submissions. So if you show me evidence that you are currently enrolled in CISP 430, I should have given you that 1 point already in that quote unquote assignment. If you see that assignment having a blank score, that means you need to show me evidence that you either have taken a class that is equivalent to CISP 430, or you're currently enrolled in a class which is CISP 430. So do we have any questions about that co-requisite requirement? Because I think that's the biggest confusion of the requirements. Any questions? Nope. Okay, all right. So I will mark it as taken care of. Okay, so we are moving on to the syllabus. So I did talk about the syllabus specifically for this class. I recorded a video about that, and I sent the link to the video to this entire class. So I hope you guys all had the chance to watch the video. Do we have any questions about the content of that video? Like, why do I scale all the scoring to 0 to 4? What is the threshold between a D and a C, that sort of stuff? No questions? All right, cool. So we can now start the actual class. Okay, so I'm trying to save some time, by offloading the discussion of the syllabus to off class time. But if you have any concern about the syllabus, don't hesitate to bring up the topic in class or come to my office hour. So, okay, this is a pop quiz. When is my office hour? Yes. And what did I change it to? 11 to noon, exactly. So it's right before this class. On Mondays, I'll be in my office, which is 316. So I should point that way because that's exactly where my office is, which is 1 floor up in that direction. Okay. And then on Wednesdays, such as today, I'll be in the STEM center. So you can find me in the STEM center. If you don't see me, it might be because I'm hiding in one of the back rooms of the STEM center. So just ask the people, the front people, and ask where's TAC, okay? If you need to talk to me in private, we can either go back to my office or we can go to one of those rooms and close the door to talk about things that you do not want other people to overhear. So are we good over there? Okay, so I hope that office hour is convenient enough that I will start to have people come to visit me and talk about class stuff. Any other questions, concerns? Nope. All right. Cool. This is Joplin. Okay, I want to show you Joplin just because I think it is really cool. On one side, on the left-hand side, you see the markdown, actual text in markdown. On the right-hand side, you see the rendering, which is kind of HTML. I think it's really cool for a class like this because it also knows how to use LaTeX. So if you have a math equation that you want to capture, it can do that. And things look really nice. I know there's a balance between learning LaTeX to represent equations and formula and so on and so forth versus handwriting. So to me, it is worth the time to learn LaTeX because I can type a whole lot faster compared to what I can write, the speed of which I can write. So to me, it is worth the trade-off. I can learn LaTeX and I can type really fast and capture the notes. And Joplin is also what you see is what you get. So on the left-hand side, that's what you type, and then on the right-hand side is the rendered version of Markdown. I find it useful for capturing notes, in lectures and meetings and whatnot. It's entirely up to you guys to decide how you want to take notes. I do want to share one thing, which is an observation. It is not a theory. I do not have any actual psychology training of any kind. But last semester, which is the first semester for most people to return to in-person classes, I have had quite a few students who got into the classroom with absolutely nothing other than a cell phone. Okay, so they would sit down, they would do a whole bunch of, I would assume, to be messaging and texting with their friends. Occasionally, like every half hour or so, they would point the camera and capture the screenshot, even though I am doing all the recording already. I have to say, just based on a non-scientific observation, those students did not do very well in my classes. So I would encourage you guys to bring, some way to take notes in classes. And the reason you take notes, I know this doesn't seem to have anything to do with this class, but I think it is helpful in the long run. People take notes for different reasons. So I take notes because I need to stay awake and pay attention. Do I ever go back to my notes to review and to study and so on? Yes, but rarely and infrequently, okay? Because I capture most of the knowledge and information from the lecture itself, okay? That's how I do things. That's how I learn. And if I don't, I would ponder, okay? I just, kind of think about things without having to read anything. A good friend of mine, who is actually, I think, way smarter than I am because he's working at a national lab and I'm not, he had to study ahead of time. So he had to study, the material ahead of time, ahead of a lecture. He takes very meticulous notes of what is happening in class. And then after class, he also has to go back and review his own notes. The reason is because he's dyslexic. So, the words, tend to be jumbled up and whatnot. So he really need the repeated exposure to really get all the information right, into his head, into his mind. So, him and I, we take notes for different reasons, but we are both, I would say, by most standard, somewhat successful in terms of, doing what we like to do, being able to do what we like to do and make a living out of it. So, just some little stories for you to share with you guys. Okay, so taking notes is important. You may be taking notes for different reasons from why I take notes, from why the person next to you is taking notes, but I think it is helpful. When you transition to a 4-year university, it becomes even more important. All right, so are we good so far? All right. You don't have to agree with me. You can say, but I can learn everything without taking notes. Hey, that's fine. Some people learn like that too. All right, so now we can actually get the class started. And I'm not sure whether I have a browser already started, but let me check that first. I think I did because I was doing something with this class earlier. Yeah, that's good. All right, so I'm going to move this window into your view and get it started. I got some plugins that are really helpful, like this one here. It's called Tab Search. So once again, it depends on how you get things done. So tab search, okay, if I click it, I can type, what I want, like, Outlook, and it will find the right tab and I can go straight to that tab, even if it's in a different window. It's really helpful because it is not unusual that I would have, 30 or 40 tabs, in a window, and then I have 4 or 5 windows of the same profile of Firefox at the same time, and then we'll have like 3 or 4 profiles, in different desktops on my computer. So searching for a specific tab, and I know that I opened that tab already, but I just couldn't find it. This is a really great tool for that. On the other side, I also have vertical tree tab. So even though I can't really quite read the entire thing here, I can read it over here. So it's easier for me to get to the right tab if I know it's in the right window. So both of these tools, help me organize and also find what I need to find, when I'm teaching, when I'm learning something new, or when I'm just programming myself, because I need to look at the language reference, I need to look at the API, I need to look at a lot of stuff, and this helps me, get to the right thing at the right time. All right, so now we can get started. And oh, one more thing. I know I just said I was nagging, so let me nag just a little bit more. Okay, give me another 30 seconds to nag. People who do not show that they have met the prerequisite or the co-requisite requirement by next Monday will be dropped. Okay, so you have quite a bit of time, but I would not put it off. Okay, just try to get it done as soon as possible. All right, so I'm done nagging. So we'll start with Boolean operators. Hopefully this is a fairly easy thing for all of us to transition into, because you have used Boolean operators in CISP 360, 400, 430, so on. So it should be nothing new until we get to the more obscure operators, in section 4. All right, we'll get started. So are there any questions about what Boolean means? B-O-O-L-E-A-N. So what does that mean? Any questions about that? A Boolean is a type, okay? Anything of the Boolean type can only handle 2 particular values, true and false, okay? So in this class, it would not be uncommon that I use 0 to represent false and use 1 to represent true. Is that okay? So instead of spelling out the words, I would use 0 and 1 to represent false and true respectively. All right, so I just want to get some of the clarifications out of the way. So we'll go ahead and start with section 3, which talks about the common things that you should know already. And those are the Boolean operators in C and C++. So we'll start with AND, which is known as conjunction. So conjunction is just the fancy word to say AND or ampersand in C, C++, Java, JavaScript, and so on. The truth table of AND or conjunction is like this. So does everybody know how to read a truth table, or should I go over that? Go over, okay. So a truth table is organized by 2 distinct partitions of columns. So in this case, we have 2 columns to represent the independent variables. So X and Y in this particular truth table are known as independent variables, which basically just means the value of X is independent from the value of Y and vice versa. Is that okay? Is that concept of being independent from each other understood? Okay, so because X is Boolean and so is Y, so we have 4 possible ways to enumerate. There are 4 ways to enumerate all the possible values of how we can combine X and Y. So what this is saying is when X is false, Y can be false. When X is false, Y can be true. When X is true, Y can be false. And then when X is true, Y can also be true. Now, this is interesting, okay? If you have never, or if you have not been exposed to Boolean truth table before, this is really cool because you cannot do this with integer operators. Like addition, you cannot just create a table that describes entirely what addition is all about. And that's because there's an infinite number of integers. Okay, but with Boolean, it's easy because we only got two. So this is a very special technique that can be useful for this entire semester, because this is how we can prove stuff using a truth table, and then we don't have to go through a lot of the algebra stuff that you normally have to go through in arithmetic. Okay, so the two columns X and Y are representing the independent variables. And then the third column is representing the value of, okay, given that X is false, Y is false, what is X and Y? So X and Y is going to be false when X and Y are both false. So each row is basically looking at a very specific case of if X has this value, Y has this value, then what is the value of the expression? In this case, it is X and Y. So is that okay, or do we have any other questions about how to read a truth table? Say again? Oh, all right. Very good. So there's a little bit of explanation here, which is probably just what I said. I think it is exactly what I just said. Okay, so the explanation of a truth table is already here. This also reminds me that you can read ahead of time, just like what my dyslexic friend used to do in college, because the way I go through these topics is really just kind of sequential, in the order that they are listed in Canvas. So if you read one particular module, you go like, yeah, I get it, and you have time or the interest, you can read ahead of the class. It's helpful to read at least one lecture ahead, because that way, even if you don't fully understand all the concepts, you have some idea of what is going on. And you can also jot down questions so that when we talk about a particular concept in class, you just go through your own question list and go like, yeah, remember, I got a question about that. And then you can just ask those questions in class. So I would strongly advise the entire class to try to read ahead of the lecture itself. Okay. All right, so we also have different notations. So X and Y is typically known as X ampersand Y in C and C++. Now, remember, in C and C++, there's also the bitwise AND, which is a single ampersand. So what we do in this class is logical AND, which is ampersand, instead of just a single ampersand. Are we good so far? All right. So the next one is, if you talk to your math professors, they prefer to use this particular symbol, which looks like a V, but it's inverted. All right. So for those of you who are thinking about, I want to give Joplin a try, except I don't know how to enter that particular symbol. What am I going to do? Well, you can do a Google search, but the best way to do it is to learn by just right-clicking on the equation or the expression, go to Show Math As, and then just go to Tech Commands. So this is, how the wedge or the TP symbol is entered. So you can, in fact, do something like this: copy to clipboard, switch to Joplin. Joplin is great because it's basically real-time rendering. So you put equations inside $2 signs or between the $2 signs. So if I just paste here, it renders on the right-hand side. So this is how you can learn how to use LaTeX to enter math equations and formulae, in a much more interactive way based on my notes, okay? Because if you just see something, it's like, wow, I don't know how tech did that. Easy, right-click, and you can learn how to do that yourself. Is that okay so far? You do not need to learn LaTeX in this class, okay? I just want to clarify before somebody asks me. Yep. Joplin? Yeah. Okay, so Joplin is what you're seeing here. And to get to Joplin, if you want to use Joplin, it is free. It's open source. You go to joplinapp.org. So this is the URL or the home of Joplin app. It is open source, which means if you want to change some of the features of Joplin, you can. I mean, it's written in JavaScript, And it's, no, I take it back. It's written in Java. Okay, it's written in Java, but the source code is available somewhere on, I think, GitHub. Nobody uses, nobody uses SourceForge anymore. Everybody's going on to GitHub these days. So all you need to do is to go to download the app, and it is available for the three main operating systems. I know most of you are thinking there are only one main operating system. All the other two are kind of like oddballs. But anyway, you can get it on all three different platforms. They work it works exactly the same on all three platforms. Once again, it is free. It's not very resource intense, so it's pretty easy to work with. If you have a Chromebook, okay, I'm not sure how many of you are using Chromebooks, but Chromebooks can run Linux. And since it is available for Linux, you can actually get Joplin to also run in Linux. I mean, on the Chromebook, which I think is kind of handy. All right, my watch is buzzing me, which means it's time to take roll. So some of you already know how I do it, and some of you are new to my classes. So let me show you how I take roll. So the way I take roll is, see, I have lost track of where Canvas is. So I need to find it again. So in structure, boolean operators. Yeah, there we go. So the way I take roll, okay, this is my habit of opening a new tab, and that's how I end up with like a bazillion tabs at any time. So the way I take roll is I go to a roll taking activity. So I'll show you exactly what it is because you need to know what the access code is for the roll taking activity. So if I go to edit, you will see that it is just like a normal quiz, but except it's not a quiz, okay? There's only one point here. And I would set it up to require an access code. So in this case, the access code is conjunction. I can also write it on the whiteboard. So not with this pen. Conjunction, all lowercase. So if you have a cell phone or if you have a laptop computer, go to Canvas. And I have not opened the activity yet. Since this is the first day, I'll give you guys until the end of the class and a little bit beyond that to enter the word conjunction. So I will make it due at 1:30 p.m., which I think is generous in terms of how much time you have to do it. And then let me show you the question. The only question you see in this particular quote-unquote quiz is, I am present in class. And it will basically give you two choices, true or false. Just for today, if you accidentally press false, you can email me and then I'll go like, okay, I'll give you that point. Okay, not a problem for today. So that's it. Okay, so save and publish, and you should be able to see the activity now. You don't have to do it now, but if you have a mobile device and it's just handy do it now, go ahead and do it now. If you do not have a mobile device and not a computer, you can go to the main lab, which is room 301 after the class and get it done at that time. It will be a little bit tight, because I make it due at 1:30. So I think most people probably want to get it done now and just to get it done and over with. Do we have any questions about the roll taking activity? Yes, so the access code is conjunction. So if you don't have a mobile device right now, or if you don't want to do it right now, you can write down the access code and then you can do it later. Okay, so if you were to do it as a student, so let me show you what it looks like from a student perspective. Okay, so I can pretend to be a student by using student view. So if you are a student, if you still have to go into Canvas, and then you just scroll down a little bit until you see roll taking, and it usually has a date code of the day. So today is the 18th of January. So you click that, and then you say take the quiz, except it's not really a quiz. It's just a really short thing that I want you guys to do. So in here, you just type in the access code, which is conjunction. And if you type in the wrong one, it's okay. It will just tell you that it's the wrong one, and you just want to make sure that you're typing the right one. So this is where you have to type, you have to answer true. And because I don't see any I don't see any reason why someone would click false. Okay, so, and then you click submit quiz. That's all you need to do. Is that okay? All right. So if you have a mobile device, do it now. If you have a laptop computer, it's on already, you'll do it now. If not, you can either send me an email with a picture of you and say, okay, I didn't have access to a computer at the time, and can you count me in as present in class? And usually I'm okay with that. Are we good so far? All right. Okay, so I'm gonna leave student view. So go back to my own view. There we go. And get back to the note. So I'm gonna take roll, I would say occasionally, because many times I would forget, because my watch would buzz me, and then I'll be in the middle of talking about something that I really want to talk about, and then forget later on, and not take roll on that day. So if I did not take roll on the day, then everybody is assumed to be present. So there you go. Okay. Are we okay so far with the process? Okay. I hope it's not too intrusive. I think it beats having a piece of paper being passed around in the class. And because of COVID and the monkeypox and stuff like that, I think passing a piece of paper throughout the class like this may not be the best idea. All right, so varying different notations of the same thing. This is in C++ when you write programs. This is for mathematicians, but for engineers, conjunction is usually represented as multiplication. So you can have a dot between X and Y. You can also just use XY in this class when you want to say X and Y. Are we good so far? So now I'm giving you guys an idea of what I would have done in this class is I would write down the symbols, because even though it's in the notes, which is freely available to you, I would put it aside in my own notes, have an area for definitions of symbols. Okay, because that would be handy later on if I forget about, okay, what does that mean? I have a centralized location to look up and go like, okay, these are all the symbol definitions, and I can always go back to that place to quickly find the definition of symbols and other types of definitions. All right, but that's just what I would do. Okay, you don't have to exactly do that. You can disagree, and that's okay, not a problem. Do we have any questions about and? Conjunction. Say it again. All of these represent the same thing. The four notations here, they all represent X and Y, just in different contexts. So in the first one, we have the math people. This is the programming, computer science programmers. This is for the math people. These two are for electrical engineers. So it's typical for electrical engineers not to use the wedge symbol. Is that okay? All right, very good. So these are all alternatives, and I can tell you which one I prefer to use for the rest of this class. Since I'm lazy, I use the last one. All right. Moving on to disjunction, which is a fancy word of or, but not either or. Okay, this is just a regular or. So this is a truth table of a regular or. 0, false or false is false. False or true is true. True or false is true. True or true is also true. So a very easy way to describe disjunction or is if at least one side of the operator is true, then the operator returns true. Is that okay? So that's just a English description of the operator. So once again, we have the three representations. In this case, we have the program representation or programming representation, which is bar bar. We have the mathematical notation used by mathematicians. It looks like a V, but it's not. The first one is a wedge. This one is called a V, as in VEP in LaTeX. So once again, if you want to learn how to type it in, this is how we type it in LaTeX. And you notice that I did not pronounce it as latex. because it is actually the first two letters, LA, those are English alphabet because they are the initial of a person. And then TEX, what we see as TEX is actually tau epsilon chi because it's from Greek. So tau epsilon chi is not pronounced as text, it is pronounced as tech. Don't ask me because I'm not a foreign language person. So if you want the most authoritative, answer to that question, you can go to the, do we have Greek classes here? No? Well, Italian, okay, you're close enough, right there, around that region. But don't tell me. It's kind of like telling people, Python and, and JavaScript are kind of the same thing. Yeah, unless you're ready to start a war, don't do that. If you want something even worse, you can tell your programming professor, but only the old ones like me. You can say, I think VI is better than Emacs. And then you just step back like a whole block and watch the firework. Yeah, because that's the one of the most debated item, for older, programmers is the debate of what is the best editor? Is it VI or is it Emacs? I mean, you guys are going like, who would use those tools? We got, VS Code. Who would use, some archaic editor like VI and Emacs? So yes, I know. All right, so the alternative representation, we have the V symbol, but in this class, because I'm lazy, I just use the arithmetic addition symbol to represent this junction. Is that okay? Is everybody okay that sometimes we use the same operator to mean different things? Yes? Does that have anything to do with all of you have taken CISP 400 and this is kind of the same thing as operator overload? Because it is. Okay. See, I don't just know, discrete field structure. I know something about object-oriented programming as well. All right, the next one is not. Okay, it's also called negation. So negation is known as not in English, and it is a unary operator instead of a binary operator, because you only have one single independent variable here, which is x. So not false is true, not true is false. So let me just reconfirm that we are now okay with how to read a truth table. Is that okay? Any questions about how to read a truth table? All right, cool. So in this case, the notations, there are 4 notations of which, in this class, I'm just going to use one of those. This is what you do in C and C++. It's an exclamation point, is negation in boolean. For mathematicians, it looks like a little cliff symbol. It looks like a minus, but with a drop at the end on the right-hand side. And this is what traditionally in engineering, in electrical engineering, they would use a bar, an over bar. And then when you describe the same thing in a circuit, they would use a slash. So those are the 2 representations used by electrical engineers. In this class, this is the way I would do it. Okay, so I am just, as a shorthand, so it's easy to type, I'm just using an exclamation point to mean logical negation. Is that okay? All right. All right, so let's do an exercise, okay? Because we just got exposed to these, symbols and whatnot. So let me just give you an exercise here, and I'll give you a random thing, so you have to tell me what does it mean, okay? So I'm going to go and put this, and we'll do something else. Okay, all right, so if I were to translate this into full-blown math, symbol, what would that be? Now, okay, I forgot to tell you one thing, which is essential, which is the priority of operators. So the operator that has the highest priority is negation. And then the next one is conjunction, and then the operator that has the least priority is disjunction. What does that mean? What does it mean when I say, there's the priority? How do you use those priorities? And by the way, that particular specific ordering of priority is consistent with how you use arithmetic negation, multiplication, and addition. So if you think about logical negation as arithmetic negation, and you think about conjunction as arithmetic multiplication, and you think of disjunction as arithmetic addition, then we are actually kind of, then you understand operator priority. So let me explain it. So we got a negation here, right? Because it's an exclamation point. The question is it negating the rest of the entire thing, or is it negating just X? Just X, right, exactly. So it's negating just X here. So that means in the mathematical notation, we'll just kind of group it all by itself using an extra pair of parentheses. I don't need to, but I think it makes it extra clear. Okay, so that's one thing. And then what? What is the next thing? The next thing is y plus z. So y plus z by itself. Okay, I'm just going back to my actual mathematical notation here. So y plus z is y or z using the right notation here. But then, since I said this is the full-blown mathematical notation, how do we relate not X, which is one thing, and Y or Z, which is the other thing? What is in between? And. It's an and. Very good. Okay, what looks like multiplication is an and. It's a conjunction. So that means, I need to use a wedge to represent that conjunction. Okay. And then what else? We have another negation here. What is it negating? Oops, I just. W and X, exactly, because the negation is always negating whatever is right after that. But in this case, whatever is right after it is parenthesized, which means the entire expression in parentheses is negated. And whatever, and that WX by itself is W and X. All right, so we'll enter that into the full-blown math notation here. So we got W and X, and then this entire expression is negated. All right, but we are still missing one thing, which is, how does this thing here, the negation of W and X, relate to the rest of the expression? Yep, that's just an and as well. So we now have another wedge over here. Oops, backslash. There we go. And I'll just put it, extra pair of parentheses. So is that okay? I mean, is that fully spelled out, how we translated from the really shorthand notation to the full-blown mathematical notation? So does anyone want to guess why I used 2 equal instead of 1? Because it is establishing the equality between the left-hand side and the right-hand side. Because I don't want to cause any confusion, because a single equal in programming is assignment. It is not comparison. So I try my best to be clear and not cause any confusion. Is that okay? Does everybody understand how we use the alternative, representation of the Boolean operators and how we assign operator priority to those operators? Right, cool. Okay, so this is a part of this class where, I would try to describe how to study or how to take a class and how to understand the material. So one way to do it is you can think of your own example, and then you come up with your own answer. But if you're not sure, you can ask me, right? In the class, you can either come up here, write your expression, and you can ask, okay, did I translate this correctly? Okay, that's one way to do it. It's really one of the best way to do it, because in the process of coming up with your own example, you are going through your mind a few times already over the same material. So that's studying. That is studying in my book. Studying doesn't have to be opening a book and just read it out loud. Okay, trying to come up with examples and say, okay, let me see if I can do this. And then when you have your answer, if you're not sure, then you can ask me, did I translate this correctly? Is that the right way to look at this expression? That to me is studying. You're also then not relying on the instructor, myself, who tend to be a little bit lazy, okay? Nobody wants extra work, right? To give you your exercise because you're generating your own exercise on your own. Is that okay? So if you say, but this is in a lecture, I can't really do this, well, spend your time outside of the lecture to do the same thing. For each hour in lecture, how many hours are you supposed to spend outside of lecture time? 2 hours, okay? Now, does that mean that you have to spend exactly 2 hours for each hour in lecture? No. Some people may be able to walk out of the classroom and say, I got at least 95% of all the material already. I'll spend another 10 minutes just to get a few things cleared up. They're done. Some other people may need extra time. It really depends, it's a personal kind of thing. But 2 hours is what the college is assuming. So that basically means people who are taking 22 units in a semester, it's physically impossible to do it. If you factor in for each hour in lecture, you're supposed to spend 2 additional hours outside of class time. Is that okay? I do want to make this clear because this is about budgeting. Okay, so if you plan ahead of time, okay, and you go like, okay, I'm taking 12, 15 units, I'm not working on the side, or it is flexible, and you look at all your time you have in a week and all the things that you want to do, all the things that you have to do, and you go like, yeah, I think I can follow this rule of for each hour in lecture, I have at least 2 hours. Then you have budgeted enough time, which is really important because whether you're successful in a class or not is not only dependent on how hardworking you are, because even if you're as hardworking as you possibly can, but you don't have enough time budgeted, you may not be able to be successful in the class. So budgeting, which is logistics, is actually very important. What happens when people run out of time, despite those people being smart, they want to achieve and they work really hard? What happens when they run out of time? We all die in the end. So that does not make any differentiation. They panic. That is the thing. Because when people run out of time, they go like, oh no, I'm not quite getting all the material. I'm not going to score well in an exam. They start to panic. They start to have anxiety. Anxiety comes from the innermost of your brain, which I normally call the lizard brain, which is actually more technically the fish brain, because we all came from fish. Yes, I believe in evolution. So that part of the brain can override the other parts of your brain. So the innermost part is your fish brain, which is in charge of what? Fear response. Okay, when you are afraid and you're threatened, something is going to happen to your life, that portion of your brain will take over in the split second, and it will cause all kinds of hormonal changes. You will feel brave, you'll feel strong, and you will be able to respond. Or you will basically also freeze, which is also a response to threat. Okay, because your predators a lot of times have a hard time hunting things that do not move. Okay, so freeze is also a response. It's a fear response. Do you think you can still think and understand all this material when you are fearful? No. So that's why we want to not try our best not to get into that state if possible. Budgeting enough time is one of the strategies to do it, because then people will not be running out of time. And if they don't run out of time, they are less likely to get anxious. Okay. If they're not getting anxious, then they can spend more cerebral time. They can spend more time with the new brain, which is the neocortex. Neocortex literally just means new brain. Okay. Which I would call the monkey brain. Okay, so you can spend more time in your monkey brain state, because that is the part of your brain that can understand concepts, that can do abstraction, that can do the coding, that can do all the logical analysis and whatnot. Okay, because when you're anxious, your monkey brain says, I'm gonna take a break. Because the fish brain says, I'm in charge here. The monkey says, okay, you're in charge. I'm gonna go take a nap. Is that okay? And once again, I'm not a psychologist, so what I just said here is totally non-scientific. You have to go take, ask your psychology professor for the rest of all the missing details. All right, cool. So now we can go back to this stuff here. All right, so once again, you might want to set aside a part of your notebook or however you take your notes just to deal with the notations and the definitions. Okay, just because, a lot of times, okay, at least at the beginning of this class, you probably need to go back to the definition and you want it to be easy to go back to the definitions. So if you're taking notes, with paper, just use a separate piece of paper and capture all of the definitions on that one single piece of paper. If you are taking notes electronically, you can probably link back to these things and just like, okay, this particular URL has the definition of blah, blah, blah. Okay. So I would suggest you guys to do that. If you want to get to a link of a specific section, how do you do that? I want to see if you guys paid attention earlier. In other words, you can get a link to the entire document. It's not going to be helpful if that thing is really, really long, right? Then you have to search for whatever you're looking for. So how do you get a link to a specific section? There's a quick and easy way to do this because there's a table of content at the beginning of the entire thing. So all of these are hyperlinks. So if you just say, okay, I just want to create a link to this junction, you just say right click here, copy link, and then paste the link in your own document. You're done. Is that okay? And I know someone is going to say, well, since you have been pushing the use of Joplin and Markdown, can you show us how to do this in Markdown? Absolutely. So you mark down. What you do is, if you want to create a link, you use the square parentheses to indicate whatever you want to type, and then the actual link will be in round parentheses. So if you do something like this, and then on here you say boolean, I think that was disjunction, right? That's it. So now you can write whatever stuff you want. You can create references to someplace else and so on. And it's because it's in electronic format. So that means after class, remember those 2 extra hours for each hour you're here. You can spend some of that time reorganizing your notes. Because the way you take note in the class is most likely going to be sequential. I used to take notes in a sequential way because I only got writing instrument and a piece of paper back when I was a graduate, when I was a student. You guys, if you use tools like this, you can reorganize it any way you want. Move them around, right? Clarify things later on, simplify. You go like, nah, that stuff is really not useful. Delete it, okay, or cross it out. Is that okay? So there we go. And we are now back to the notation stuff. So we are now done with the 3 operators that all of you should be fairly familiar with, which is and, or, not. So in this class, just for fun, I'm going to introduce NAND. So this is NAND, which is N-A-N-D. It is negated AND. Negated AND is interesting. And this is the definition, okay? The definition of NAND is this. This is, I don't know why, I sort of know why they use this as an operator of negated AND. The up arrow thing here, that's the operator representing NAND. But what it really is just the negated conjunction of 2 values. Are we good so far? Does everybody understand what is negated AND, which is also known as NAND, N-A-N-D? Is that definition okay? So the definition by itself has no particular meaning. All that is saying is, if you see the left-hand side, it really is the same thing as the right-hand side. Okay, that's all it's trying to establish. It's really just that. It's a shorthand, Okay, you can look at this as a shorthand. But NAND is interesting because this is the one operator that you need to make up the rest of the operators. So negation can also be done using NAND. So the negation of X can also be done with X NAND itself. And then X and Y can be done with X NAND Y, NAND, X NAND Y. And then X or Y can be done as X NAND X NAND, Y NAND Y. All right? You guys go like, how do we know you're telling us the truth? How can I verify this? So this is the other thing that I would encourage all my students to do, is to question the validity and the sanity of tag. I don't encourage you to do this to all of your other professors, but you can do it to me. Because asking questions like those questions is always a good thing. There's nothing bad that can come out of it. So the question now is, what is the validity? Okay, the sanity thing is kind of subjective, so we can talk about that in some other situations. But the validity part is like, yeah, but how do we know this? The first thing is you want to come up with the truth table of NAND. Now that is missing here. You go like, Tech, didn't you forget to write the truth table of NAND? Well, yes, but I'm gonna say, yeah, but this is a perfect opportunity for you guys to do it as an exercise. So how do you make a truth table for NAND based on how it is defined? So let's do this in Joplin, okay? Because I want to show you Joplin, and I also want to give you the answer along the way, and hoping that you guys are all participating. So I'm looking forward to some 40 monkeys kind of hopping around right now, because it's your monkey brain that is supposed to be doing this work. All right, so let's do a copy and paste first, because I want to make sure that the definition is visible when I get back to Joplin. So now we are in Joplin, and we'll go ahead and paste the definition first. So you guys can focus on the right-hand side unless you're trying to learn Markdown. So now I want to generate the truth table. So the other thing Markdown can do is it can do a truth table relatively easily. So a truth table, a table, any table. So a table is done by just making something that looks like a table. So we got X, we got Y, and then we also got X and Y, or X NAND Y, which is okay. Let me just use the other notation because I think it's easier to understand the C++ notation. So I'm going to use the C++ notation here, which is not of X and Y. Because in this way, I don't have to worry about people, not being familiar with the concepts that we are currently talking about. All right, so X can be false, Y can be false at the same time, and then we need to figure out, the expression. X can be false, Y can be true, and then we want to figure out the expression, and so on. So I'm just using a shorthand here, so I don't have to retype everything by hand, like so. Okay, so now we just have to fill in the blank, okay? So you guys don't have to focus on this side, I'll deal with that side. You only have to deal with this side here. So can we all recognize this particular C++ expression? I hope so, right? Okay, so if X is false, Y is false, what is this expression going to give? Going to give us true, right? Because X is false, Y is false, false and false is false, not false is true. Okay, so let me just put that here. This is true. What about the next row? Okay, we have X being false, Y being true. So what is the negation of X and Y? It's once again true, because conjunction is false if at least one side is false, right? So that means this is going to be true, this is going to be true. This is the only time when you have two truths on the left-hand side and the right-hand side of the conjunction. So the conjunction itself is going to say true, but since we are negating the conjunction, so after the negation, we get a false. Are we good so far with the truth table of NAND? So given this table, we can work out the other claims, okay? So I will leave it to you to do that, okay? Because I think this is going to be a good exercise, is to use a truth table to show that not X is the same thing as X NAND X. I'll do one of these, you guys will do the rest. How about that? Okay, I'll do the easy one, you guys can work on the slightly harder one. All right, so let me work on the easy one, okay? So once again, we are using a table. So we got X. I want it to look nice, so I'm using the backtick. Anything within a backtick is verbatim. It is seen as quote-unquote code. So that's why it looks a little bit different. And in this case, we now have the negation of X and X, because it's just X NAND X, which is that. Yep, okay. All right, so we only have one single independent variable, which means it can be true, it can be false, and it can be true. So we have to figure out what happens when X is false. What happens to this expression? I got an extra backtick. Let me get rid of the extra backtick because I forgot about the end backtick. There we go. So focusing on the right-hand side, if X is false, what is X NAND X? It's going to be true. Okay, very good. So we'll go ahead and put it true here. What if X is true to begin with? What is the negation of true and true? It's going to be false. Okay, fine. So now I'm going to add one extra column, which is just the negation of X. All right, so we'll adjust the table accordingly. So what is not X when X is false? True, right? How do we know that? How do we know that we are supposed to put a 1 here because it's true? We had a truth table earlier, okay? So even if you have not taken CISP 360 prior to this class, we just talked about it, okay? So this is, this is also important in terms of studying is a lot of times, you have to make sure that the earlier concepts are understood and absorbed before you move on. Because otherwise you won't have a good foundation for the later concepts to stack on top of. Okay, so now we have the truth table. Now this is an interesting truth table because we only have one single independent variable. The other two columns are corresponding to two different expressions, and we want to see if those two expressions are equivalent or not. How do we know those two expressions are truly equivalent? Exactly. For all the rows in the truth table, the two expressions gave us exactly the same answers. Okay? Is that okay? Does everybody understand, how we can establish equivalency between expressions based on the truth table values? This is a very useful technique to prove whether two expressions are equivalent or not in Boolean algebra. This is not a technique you can use in normal math, but in Boolean algebra, it's a very, very powerful technique. Is that okay? All right. The dollar sign? The dollar sign is used to surround a math equation. The wedge is what produced this conjunction of the operator. So that's the market notation, which you do not have to learn. Okay, so what you guys can do is to focus on the right-hand side, unless you also want to learn markdown. It's a useful thing to do, but not everybody wants to learn, discrete math along with markdown at the same time, okay? Because it's like two different things, and it's helpful to learn both of them, but if you only get want to learn one of them, I would just choose to learn the concept in this class and not so much Markdown. So are we good so far? So can you apply? Do you feel comfortable applying the same technique to show that X and Y is really the same thing as X NAND Y NAND X NAND Y? And then X or Y is really the same thing as X NAND Y NAND Y. I mean, after you're done with one of them, you probably will go like, yeah, I know how to do with the other one. But do you know the process? Do you know the technique? And do you know how you can look at the truth table and say, yeah, they are really the same? Are we okay with that technique? Cool. So the conclusion of this part of the lecture is not really productive, but it is interesting nonetheless. Because all this is really saying is the operators that you have learned in C++ is not really necessary. They could have just introduced a single Boolean operator called NAND and be done with it. Is that okay? So you can give it a try, okay? Next time you write a program in C or C++, you can use the macro definition, or you can use a function to define NAND. And then instead of using not, logical AND and logical OR, convert everything to NAND. Do that only if you have a lot of time on your hand, okay? Because even though there's equivalency, it is not going to be easy to read, okay? Just partially because we are not used to it, and also because it is a more, just look at this. This is not really exactly a concise notation. But the interesting part is we don't really need the other three operators. I think that's the most important, the most interesting part. And somebody's going to say, so Tag, are you just going to spend and waste all of our time to talk about things that are interesting but not applicable? Well, not exactly, because in electronics, there are such thing called EPLD, CPLD, and also there's one thing that I forgot. Gosh, I cannot remember the name, the acronym of that thing. They're called programmable logic devices. Your cell phones have it. The Raspberry Pi Nano, which is the new Raspberry Pi, also has it. Okay, it's basically a programmable logic array so that you can define your own circuit on the device to do specialized processing. So this is real. Okay, this is a real thing, because a lot of times, in order to optimize the use of electronics, we can leave certain things unprogrammed. So this way, how we utilize, how we establish pathways between the components on your cell phone, on your computer, on various types of computational devices, that can remain to be reprogrammed later on. So we can make better use of the resources depending on what we want to do. So some of those devices are made out of just NAND devices. Some of those are only made out of NOR devices, because you're basically looking at one gigantic array of NAND gates, or you're looking at a gigantic array of NOR devices. What is programmable is how you hook up the output of one to the input of the other one. So you can change the routing between the input and the output of a whole bunch of NAND gates or NOR gates, depending on the technology. So how is that related to this? So even though to us, not and or are more natural, more intuitive, you need a compiler to compile the expressions that are expressed in not and or to either NAND or NOR. So that part is realistic, okay? Because there are such things called CPLD, EPLD, and I just cannot remember the other one, but they are programmable logic devices. And they are there to optimize the use of resources of your Fitbit, cell phone, laptop computers, and all kinds of other devices. So it may not be something that you need to know or you apply right away, but I think somewhere along the line, you might find this discussion to be useful. That would be about 10 years down the line, and you guys will not remember me at that time. So are we okay so far with this? Okay. So next one is a confusing operator. It's implication. So implies, most people do not see imply as an operator, because it is not a word in English that we usually associate as an operator, but it is an operator. So we are going to use the double bar right arrow is what I use as implication. In some other textbooks, they use a single bar, but I use a double bar because I use a single bar arrow for something else. So this is how we define implication. Now, no matter how you look at this is the truth table of implication. So once again, we have x and y as independent variables, which means the value of x does not depend on the value of y and vice versa. So now we have the truth table having exactly 4 rows, just like the and the or. And now we are defining what is x implies y given the values of x and y. So this may be a little bit interesting because what it's saying is false implies false is true. False implies true is true. True implies false is false. And then true implies true is true. In other words, the implication itself has a value of either true or false. So I'll pause a little bit here and just let you guys spend some time to absorb the concept that the implication itself can be true or false. Do we have any questions about that? Are we all comfortable with the concept of the implication itself can be true or false? Yeah, go ahead. What is the point of having it? Because every single proof is based on a chain of implications. And we want all of those implications to be true. Let me try to kind of help visualize this. So this is on the whiteboard and it's not going to be captured in Zoom. Okay, but I think it's going to be okay because it's just a quick visualization. What is a proof? I mean, all of you have taken Math 372 or something equivalent to Math 372. In other words, you know algebra. You know how to prove certain things already. So what exactly is a proof in mathematics? Yep.
I think you usually relate like x is equal to something and like you connect it back in the end.
So you usually is given a equality. And then you're given certain other things, and you are asked to say, how do we know that if we are given these things, then that thing over there, that equality over there is going to be true. Okay. So in terms of graphical representation, you might be given certain things. Okay. So these are the things that are given to you. Okay. They can be axioms. They can be theorems that have already been discussed in class. They can also be just things within that question here. It's like, assume x equals to 6.5. Okay. So all of those things are given to you. They are all given to you and say, all of these things are true. Don't bother to ask why they're true. They're just given to you as true. Okay. And then there's this one thing here, which is what you need to prove. This is where you need to end up with. Is that okay? So is that kind of your understanding of how a mathematical proof usually is formatted? You've got a bunch of stuff that is given to you, and that can include axioms that have been discussed in class, other theorems that already have been proven, blah, 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 right? And then there's one little destination here, that you have to arrive at. It usually is an equality, but it doesn't have to be equality. It just has to be something that is either true or false. Is that okay? So the steps of a proof is basically to say, if I look at these two together, it's going to imply this thing. This is new. Okay, this is not given to you verbatim. Okay, this is something that you derived. But nonetheless, there's an implication. The implication is saying if this is true and this is true, then that also has to be true. So now you basically go like, oh wait, if I combine these two, it's going to imply this thing here. And if I combine these two, it's going to imply this thing here. And then these two together is implying this thing here. And then if I combine this one with this one, it's gonna imply this thing here. And if I combine this one and this one, it's gonna, now you tend to, circle there. These two is gonna imply this, and then, this in return is going to imply that. That is a mathematical proof. It is using implications to link everything that you are given with eventually to the one thing that you are asked to prove. Yes,
How this not and like you were saying if this is true and this is true, how is this implication and not and
how does it?
like you have two things and you're saying if this is true and this is true, like why
Right.
is this not and it's implication? Like
He's
you
not
have
using and as a boolean, he's using and like a normal word, like.
Well, in this case, I am using and as a conjunction, but it doesn't have to be. In other words, for each implication, there is the left-hand side, which we call the precedent, and then there's the left-hand side, which we call the consequent. The precedent itself, which is on the left-hand side of the operator, that has to be true first in order for the implication to be useful. But if we know, this is true, then the other side is going to be true in a valid. So when I use the word and, I'm simply, I'm simplifying this whole thing here. So when you look at, these two things, it can be a conjunction, it can be a disjunction, it doesn't matter. Because all we want to know is whether the left-hand side of the implication is true or not. Okay? So that is why the implication is useful as an operator, because each implication is one step in a proof, so that we can start with something, and then we can establish the truthfulness of something else. And that is something that's yeah, go ahead.
So implication can be kind of moving off, but that's like a definition.
You mean this one here?
Yeah.
You can use that as a definition. You can also use the truth table as a definition. They are equivalent. They are equivalent. So hold that thought and let me answer his question. This is how implication is defined regardless of who is teaching it. Oh, okay. Yeah. So there are very few things that I actually introduce in this class that is me only. This is actually how implication is defined. So the other thing you can also do, this is another ungraded assignment where you can go ahead and do and just get some practice, is to show this. Okay, so let me, nope. Okay, prove that x, right, arrow, that is how we get the imply symbol, is really the same thing as if I use the all math operator, it is the negation of x or y. Use the truth tables, okay? So start with the truth tables that I have already given you to show that x implies y, according to its own truth table, is really the same thing as not x or y. Is that okay? Yep, go ahead.
So the negation only applies to X, not.
That is correct. That's why I put in the extra parentheses, which is really not needed because of the priority of the operators. But I want to make sure that people understand that negation applies only to X and not the disjunction itself. All right, so do we have any questions about how to start the process? How to start with that proof? How would I do it? Okay, so the idea is to make a truth table. And your truth table, okay, so I can give you the format of the truth table to get you guys started. And because I'm lazy, I'm just gonna copy something that I got already, which is this one. All right, except this time, we do not have that expression, and instead we have x implies y, right? So we have x implies y. And then we also have an extra column of the negation of x or y. Okay, so that's our table. And I'll get you all of this stuff here. So now, since we have two independent variables, how many rows do we have? 4 rows, because it is 2 to the power of 2. So false, 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 true, true, false, oops, and then true. So your job is to fill in the other 2 columns, okay? Did I miss a row, or it's just not shown? It's just not shown, I think. There we go. So your job is to fill in all of these blanks here. This column is super easy because you can copy and paste. Because the truth table of implication is given to you already. Okay, that's a done deal. Is that okay? This is the only thing you have to figure out. So now you have to ask, given that x is false, given that y is also false, what is not false or true? Or false, sorry, not false or false. Figure out that value over here. Next row, x is false, y is true. Figure out what is not false or true. Next row, x is true, y is false. Figure out what is not true or false here, and so on. Then you have to look at these 2 columns and see if they have exactly the same value for each row of the truth table. If they do, then these 2 expressions are equivalent. Is that okay? So I would suggest doing that before the next class, because it is a you can see that as an exercise of using what we have already learned in this class, and also the technique of using a truth table. Is that okay? Yep.
That truth table would be enough for the proof.
Yes. So a truth table can be used as a proof in Boolean algebra, and that's why the Boolean algebra is easy, because of the special technique of being able to use a table and show that, hey, for every single way to combine these values, we get the same value. All right, so we are running out of time. If you want to talk to me, because it's the first day and I just changed the office hour, so if you want to talk to me after class, I can probably do another half hour or so. If not, I'll see you guys on next Monday. So what do you do over all those days between now and next Monday?
Exercise.
Do the exercise, okay? Review the content, and I will send a link to you guys so that you have access to the recorded lecture. All right? All right, so you can contact me, by email over, these, days, and you can also visit me in my office and so on. All righty. Have a nice weekend. Yep.
Last semester we had the CISP exam. You were late and asked how to go like earlier. Is this gonna be the same this semester? The last semester you let us go earlier. Remember?
Right.
Because of the lab. Is this gonna be the same this semester or not?
This is not going to be the same because we only have a lecture, and I always use the entire duration of the lecture.
Okay.
Do you have a class right after this that you need to kind of really hurry to? Oh, okay.
I have 40 minutes
Oh, okay.
till the next, just because of the Monday, like my schedule and my parents' schedule is not really good. Like,
I see.
yeah.
Yeah, I tend to use up all the time in the lecture.
Okay, that's
Yeah.
right.
Yeah, but there's no lab in this class, so.
Thank you.
Mhm.
Have a good day.
Yep, you too.
What's the priority?
And then exercise.
Priority? Okay, give me a second here so I can try.
Where's, can you find the report?
I was, remember what I said?